Inside the computer, binary data is always moving. Programs are loaded from storage into RAM. The CPU fetches the data and processes it. Inside the processor, registers and the ALU work together to perform calculations at incredible speed. Every operation is carried out using only binary, zeros and ones. Binary data moves through several parts of a computer. First, it is stored in secondary storage. When needed, it is loaded into RAM. Next, the required data moves into the CPU registers. Finally, the CPU processes the instructions using binary to produce the result. Secondary storage keeps your files safe for the long term. This includes SSDs, hard drives, USB flash drives, memory cards, and optical discs. Even when the computer is turned off, the data remains stored. Inside every file, everything is saved as binary, using only zeros and ones. Every file inside a computer is stored as binary: a photo, music, documents, videos, and games. They may look different to us, but inside the computer, they are all patterns of zeros and ones. When you open a program, it is copied from the SSD into RAM. RAM stores the programs and data currently in use. Because RAM is much faster, the CPU can access it quickly and run your applications smoothly. RAM is divided into many memory locations. Each location has its own unique memory address. The CPU uses these addresses to quickly find the data or instructions it needs. Without memory addresses, the computer would not know where information is stored. When you open a program, it cannot run directly from the SSD. First, the program is copied into RAM. Then, the CPU fetches the instructions from memory and begins to execute them. This is how every application starts running.
Inside the CPU, there are tiny storage locations called registers. Registers hold data, instructions, and memory addresses that are needed immediately. Because they are inside the processor, they are the fastest storage locations in the computer. Before the CPU can process data, it follows a simple path from storage to RAM, from RAM to the CPU registers, and finally to the CPU, where the instructions are executed. This journey happens millions of times every second.
The closer data is to the CPU, the faster it can be accessed. CPU registers are the fastest, but also the smallest. Next comes RAM. Then, secondary storage, which is much larger, but slower. In computers, faster storage usually means smaller capacity.
The CPU is the brain of the computer. It receives binary instructions, processes them at incredible speed, and sends the results to other parts of the system. Every calculation, every decision, and every program depends on the CPU. The CPU understands only binary instructions. It performs calculations, makes logical decisions, moves data, and controls the other components of the computer. Every task starts with binary and ends with the result. The CPU works in a continuous cycle. First, it fetches the next instruction from memory. Then, it decodes what the instruction means. Finally, it executes the required operation. This fetch, decode, execute cycle repeats millions of times every second. When you open a calculator application, the program is loaded from storage into RAM. The CPU fetches the instructions, places the required data into registers, processes the calculation, and finally displays the result on the screen. Inside the CPU, the ALU performs binary calculations. It receives binary values from the registers. The ALU adds, subtracts, or compares the data. Then, it produces a new binary result ready to be stored or displayed. The arithmetic logic unit, or ALU, is where the real calculations happen. Binary data enters the ALU. It performs arithmetic and logical operations, then produces a new binary result, ready for the next instruction. Each computer component has a different job. Storage keeps files for the long term. RAM holds programs currently in use. Registers store the data needed immediately, while the CPU processes instructions using binary. The closer data is to the CPU, the faster it can be accessed. Registers are the fastest, but very small. Next comes RAM. And finally, secondary storage, which offers the largest capacity but the slowest speed. In computers, faster storage usually means smaller capacity. Don't confuse the different parts of a computer. RAM is not the same as secondary storage. Registers are inside the CPU and much faster than RAM. Programs must be loaded into RAM before they can run. Remember these differences, and you'll avoid common exam mistakes. Let's review how binary works inside a computer. Programs are stored on secondary storage. They are loaded into RAM. The CPU uses registers and the ALU to process binary instructions. Finally, the results are displayed or saved. This is how every modern computer works with binary every single second.